Hi everyone, welcome back to the coding series. In today's video, we will be solving LeetCode problem number 31, next permutation. Let's get started. Let's understand the problem statement given here. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, for array equal to 1, 2, 3, the following are all the permutations of an array. Now you have to find the next permutation for a given array. That is defined as the next permutation of an array of integers is the next lexicographically greater permutation of its integer. Now let's understand what they meant. For a given array, you have to find the next permutation. Now consider this array as a number 123. So now you have to find the next nearest greater element to the 123. That will be 132, right? So 1, 3, 2 will be the next permutation for a given array 1, 2, 3. Similarly, for 2, 3, 1, the next permutation will be 3, 1, 2. Now consider 3, 2, 1. You have to find the next permutation. But we don't have the next permutation for this 3, 2, 1. In that case, what you have to do is you have to sort the given array. After sorting, the array looks 1, 2, 3. Now you have to just return that. So 1, 2, 3 becomes as the next permutation for 3, 2, 1. And they have clearly mentioned that you have to do the changes in the given array using extra memory. Now let's dive into the approach. Take an array 1, 2, 3. Okay. For this, the next permutation will be 1, 3, 2. How we can achieve that? Okay. For that, first find the last increasing element. Okay. Here, when you consider this array, 1 is less than 2. Yes. This is the increasing element. Now 2 is less than 3. Yes. So the last increasing element becomes 3. Okay. For 1, 2, 3, the last increasing element is this one. Element. Okay. After finding the last increasing element, you have to find the nearest smaller element to the left of the last increasing element. Okay. Then 2 becomes the nearest smaller element. Right. This will be the smaller element. Now what you have to do? Now you have to swap to 1, 3. Okay. After swapping, the array looks 1, 3, 2. Okay. See, we have achieved the next permutation for 1, 2, 3 is 1, 3, 2. Okay. What I meant is, now let's understand for one more example. Now let's take 2, 1, 3. Okay. 2, 1, 3. Okay. Here 2 is not less than 1. Okay. This will not become the increasing element. Now 1 is less than 3. Yes. This becomes the increasing element. Here also 2, 1, 3. This is the last increasing element. Okay. Now you have to find the nearest smaller element to the left of this. So 1 becomes the nearest smaller element. Okay. Now what? You have to swap this. Okay. Then the array looks 2, 3, 1. Okay. For 2, 1, 3, the next nearest or else the next permutation will be 2, 3, 1. We have achieved that. Okay. So now let's understand the one special case. Okay. Now let's take 1, 2, 5, 3, 6, 4, 2. Okay. Its next permutation will be 1, 2, 5, 4, 2, 3, 6. Okay. How we can achieve that? Now find the next find the last increasing element. Okay, 1 is less than 2. Yes. 2 is less than 5. Yes. Now 2 is less than 5. Yes. 5 is less than 3. No. 3 is less than 6. Yes. Again 6 is less than 4. No. 4 is less than 2. No. No, right? This is the last increasing element. Now what you have to do? For 1, 2, 5, 3, 6, 4, 2, and the last increasing element is this one. Okay. Now you have to find the nearest smaller element to the left of this. Okay. So the nearest smaller element is 3. Now after you find the nearest smaller element, what I told in the beginning, you have to swap. Okay. After swapping, the array looks like this. Okay. But this is not the next permutation for this array, right? How we have to achieve this? Okay. Now we have found the 3 as the smaller element. Okay. Now what you have to do is you have to check the right side of the last increasing element. Like check all the elements. Okay. Whenever you find any element, check the right side of the last increasing element. Whenever you find any element, you have to, like, whenever you find any element that is greater than the smaller element. Okay. Here 4 is greater than 3. Okay. And this element should be less than the last increasing element. And 4 will be less than 6 also. Okay. In that case, what you have to do is you have to swap 3 comma 4. Okay. Now 1 comma 2 comma 5 comma 4 comma 6 comma 3 comma 2. Okay. What I meant is, see here you find the smallest element. Okay. And what you have to do after finding the smaller element, you have to check whether there are elements to the right side of the last increasing element. For 1 comma 2 comma 5 comma 3 comma 6 comma 4 comma 2. Okay, this is the smaller element, this is the larger element. Okay, last increasing element. Okay, now you have to check whether there are elements or not to the right side of the last increasing element. If yes, you have to check whether the element, any element to the right side of this is greater than the smaller element, but it should be lesser than the last increasing element. Okay. In that case, you have to swap them. Okay. After swapping, the array looks like this, right? After swapping, the array looks like this. Now what you have to do? You have to swap the after after swapping, the array looks like this. Now you have to swap the elements starting from the index of the last increasing element. So after swapping, the array looks 1 comma 2 comma 5 comma 4 comma 2 comma 3 comma 6. Okay. See, 1 2 5 4 2 3 6. For this 1 2 5 3 6 4 2, the next permutation is this one. Okay. We have achieved that 1 2 5 4 2 3 6. 1 2 5 4 2 3 6. Here, first find last increasing element. Okay. After that, what you have to do? Find the smaller element to the left of the last increasing element. element. After that, what you have to do? After that, check whether elements to the right side of last increasing element, whether that element is greater than smaller element that we have found earlier, but that element should be less than last increasing element. In that case, you have to swap those elements. Swap this element with the smaller element. Okay. After that, sort the elements to the left of the last increasing element. Sort the elements sort the elements from the index of the last increasing element. Okay. Now let's take one more example. One more example as 231. Okay. 2 comma 3 comma 1. Okay, what I have told, you have to find the last increasing element. 2 is less than 3, yes, but 3 is not less than 1. Okay, the last increasing element, this one, you have to find the nearest smaller element to the left of this, that will be 2, right? Now after you found what I told, you have to check the elements to the right side of the last increasing element. If any element is greater than this, you have to swap that. Okay, here 231. Okay, here 231, here 1 is not less than 2, 1 is not greater than 2. Okay, in that case you don't do anything, just swap those elements. 3 2 1. Okay, after that your last increasing element index points here, right? From there you have to sort the elements. So after sorting, the array looks 1 3 comma 1 comma 2. Okay, so for 231, the output is 3 comma 1 comma 2. Okay, so similarly, when I told for 1 comma 2 comma 3 in the earlier, when I took first example, we got the this as the last element, right? So the next nearest smaller element will be 2. Okay, what I told you, have to just swap these elements. Okay, because to the right side of this there are no elements, so for this smaller element you don't need to check anything. Okay, simply you have to swap. So for 1 comma 2 comma 3, the output, the next permutation will be 1 comma 3 comma 2. Okay, now okay, here we didn't see about this, right? Here if no such increasing element exists, meaning 5 4 3 2 1, here 5 is not less than 4, 4 is not less than 3, 3 is also not less than 2, and also 2 is also not less than 1. Here we don't have any increasing element only. In that case, you have to just sort this array. So this becomes as the next permutation for this given array. Now let's code this. Let's see. Let's take these points. Okay. Here what I have done. First I have took the array length. Okay. First I have initialized this n with the array length of an array. Now if you have only one element, you can just return. Okay. Now last greatest element. Here find the last increasing element. Okay. Here last increasing element is initially I took that as a 0. Okay. For I equal to 1, this is the logic to find the last greatest element, last increasing element. Okay. If initially this is as a initially we have took last greatest element as 0. Okay. If you do not found any last increasing element, then it will be in the array will be in the descending order. In that case, we have to sort that and you have to return that. For that, the logic is this one. Okay. After that, for suppose we have the last increasing element. Okay. I have initialized that to index. This is the logic to check whether okay and yeah okay. This is the logic to check. So the next nearest smaller element will be nums of last greatest element minus 1, right? You have to check whether elements to the right side of the last greatest element, if there are elements, then you have to check the smaller element should be less than the right side of the elements to the last greatest element. Okay. If this condition pass, then we have to swap that smaller element to the element that we have found. Okay. This is the swapping logic. After that, what I have done, we have to sort the elements to the from the index of the last greatest element. Okay. Now we'll see whether test cases are passed or not. See. Now we will submit. Yeah, all test cases are passed. Here we have used O, we have iterated over n elements O of n. Similarly, so the time complexity for this will be O of n. Okay. In the worst case, it will be O of n log n. If you do not find the last greatest element. Okay. Then the space complexity. We have just took the extra two memories, this one and this one. So the space complexity will be O of 1 and time complexity will be, in the worst case, it will be O of n log n. Okay, that's it guys. If you have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.